Hello, you're welcome to this session. My name is Oladimeji Kazim. Uh, I'm a business and data intelligence expert. I've been around for some time, um, working on good projects that enables me to be able to drive a session of this nature. We shall be looking at visual analytics with Power BI and Python. The entire activity is divided into sections, into modules, but the modules are subdivided into sections. Let's kick off. The overview of the course involves talking about visual analytics. What is it all about? What has it got to offer? What is it important to the business? Why? Then the various objects of visual analytics. At some point, we'll look at the use cases for visual analytics, talking about the business cases, the stakeholders, and various possible roles in visual analytics within an average organization. Next, we'll look at introduction to Power BI, talking about a dashboard, what does it look like, what are the reports looks like, including Power BI and mobile apps. We'll look at a thorough session where we shall develop a dashboard for an organization. This time around, we're going to look at a dashboard for CRM, which considers performance with respect to customer feedback. Afterwards, we'll look at introduction to Python, where we shall basically talked about pandas and basic NumPy. Pandas for tables and related objects, while we use NumPy for data manipulation and the rest. Afterwards, we conclude the whole thing with a data visualization exercise, which involves the use of some visualization packages like Matplotlib, Plotly, and the like. And that helps us to go through the entire course. Now, this implies the whole course is divided into 6 modules. Now, we shall be looking at them one module at a time. The first module talks about an overview of visual analytics. What is it all about? What do we mean by understanding visual perceptions? How do we communicate visual insights to business world? And what are the objects of use? In today's organization, you will all agree with me that data is becoming something very relevant. Looking at the following perceptions from an organization: how many calls were received monthly? How many calls were received quarterly? How many calls were received annually? What are the origins of the calls? Why were they made? And what happened to be the top 5 types of these calls? Are we talking about service? Are we talking about fault? Are we talking about bad product? Are we talking about bad service? Are we talking about people? What are the top 5 types? Now, how many of these calls translate into business opportunities? Sometimes when calls come, those calls could translate to a new business sales. How many of the issues reported were resolved? What are the customers' major complaints? So these are the perceptions, these are the things, these are the kind of issues, these are the kind of questions that brings about the use of Power BI, visualization tool, and the rest. Talking about visual analytics, it is like a roadmap. It has its own structure, like a framework, which is summarized as shown. And the whole thing starts with a task That is, you frame a particular business problem where you talk about what the challenges are, like the questions that we just looked at. Afterwards, data is put together based on the business problem. For example, there is a business problem that implies the company needs to conduct a kind of survey. This survey generates data, and the data generated is stored in this environment, that's in a data repository, from where a business analytic tool is expected to be connected to it for visualization. But before being visualized, the data must be mapped to various questions. After being mapped to various questions or various problems to be solved, then the data can be viewed. Now, when data is viewed by people that have the right to look at them, and we are able to see insights have been discovered, then this insight is shared with business process owners, either business process owners or business executives. That is the flow of data within the visual analytic terrain. So basically, looking at it from this angle, we can actually go from getting the data to viewing the data, depending on how complex. That is, moving from getting the data to view the data, depending on how complex the problem is. At the same time, from viewing the data, we can share the insight in the data directly if there is no need to do further analysis or further activities on it. Just in the same vein, getting the data means you can share the data directly, depending on how simple or how difficult it is. What are the visual objects being used? There are visualization objects. There are so many of them. So every framework has its own visualization object. But some of these objects are common to all visualization objects. The first of them is the bar graph. When you talk of bar graph, you want to see how some categorical data are performing. What we put in place in such a situation is to use a bar graph. Bar graph allows us to put them together. At the end of the day, we're able to compare the features in the data. We're able to rank them. Then we can change from bar graph to bump chart if that's what's of use to us. So basically, that is the way bar graph works. And in a similar manner, we can make use of pie chart if we know that data is basically categorical. It's just a categorical data that's not doing anything else but just to see. Again, the next one is line graph. Using a line graph implies we are talking about data that keeps moving, maybe over a time, over a year, over a period, over a week, over a decade. That is a line graph works in such a situation. You are talking of something temporal in such a way that the data being generated is not static. It keeps moving. So that is, we are expected to make use of line graph with such. The next one is a histogram. Using the histogram, we have data that keeps streaming. They are continuous data. They are not categorical, but we just need to be able to put them in special perspectives, like a block called bin. So that helps us to be able to look into the data and see what works. For example, the age of students in a class, the age of students in a school, the height of students in a school. These are data. This is the kind of data that we take into the histogram. Histogram, because it is very difficult for us to say we would like to represent every child in a school, the age of every child in a school with a bar. It's not possible because there are so many children in the school. Rather, we'll take a common block. Perhaps, say, between the age of 10 and 15, between 15 and 20, something like that with common bin, common block, common space between them. So we look at so that we can group people together, group the children together, and have some activities within each group. So the assumption will be that whatever happens within that group is common to everyone within the group. So a histogram is a good stuff when it comes to distributions, to represent trends. Instead of using histogram, sometimes we make use of bar plots. Box plot. Box plot, we are going to look at it extensively at some point. It's good. It works the way histogram does. The difference is just that it gives much more information than histogram. Then the next one is scatter diagram. We use the scatter diagram to represent distributions, feature correlation, or relationship that exists between two variables. Another tool that is used in such a situation is the heat map. So it is either we use scatter diagram or we use the heat map. Then we have the tree map. Tree map represents data using a hierarchical relationship, and is used when space is a constraint and you need to present so much. We use it to expose data pattern that can hardly be exposed by any other tool that we have mentioned. The next one is the box plot. Box plot looks like the relationship between a categorical feature, and numerical feature. Present the situation, present the data such that there will be some meaning to what the data contains. So it can be used along with other plots, and at the same time, it allows large data set in small space. When you compare this to the histogram does not allow, it will be difficult for you to use histogram when the data set becomes so large. But with box plot, this can be achieved easily. Then the last one I have here is the heat map. This shows the relationship between two features using colors. The colors that is close to one extreme shows some relationship towards that extreme, and the colors that goes to the other extreme does the same thing. So depending on the situation, like if you look at this now, I have a variable here, we have another variable here. These colors here that are dark here, they are closer to this place. And if you look at this correlation here, it shows that correlation is lower here towards 0, it's lower here, and it's higher here towards 1 here, which implies that all those ones that are dark, they are closer, they have very low correlation relationship. So the relationship between this variable and this variable is such that they are very low, whereby correlation between this and this at this point is very high. It's very high here because they are closer to this lighter side of the bar. So basically, this is the way heat map works. Questions? Thank you. Thank you.